Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank the panels and most importantly to my supervisor, Dr. Shahida binti Muhammad Shah, who helped me a lot to complete my PSM2 project. My name is Muhammad Khairi Azizi bin Shamsuddin, metric number AN170082 from Bachelor of Electrical Engineering Technology Electrical Power with Honours from Faculty of Engineering Technology. This video is produced to present my PSM2 project entitled Solar Power System with Dual Axis Solar Tracker and Monitoring System for the Gateway Station using Arduino and NodeMCU. First of all, I will present the abstract of this project. Solar energy is a non-disappearing renewable energy source that is free from the atmosphere. The problem with solar energy, however, is that it relies directly on the strength of the sun. In order to produce the maximum amount of energy, the solar panel must be perpendicular to the light source. When the photovoltaic panel is perpendicular to the sun, the solar energy conversion efficiency increases. Therefore, the aim of this study is to propose an innovative method to track the sun using a light-dependent resistor LDR. It is rational to conclude that the points of the brightest region in the sky indicate the position of the sun. The information on the location of the sun center is sent to embedded processor to power two servo motors capable of moving horizontally and vertically to track the sunlight. The IoT is used in this study purposely for monitoring the performance of the solar power system and the dual-axis solar tracker. The data helps to make the decision to plan operations, repairs, and preventive maintenance. For introduction, in the process of generating solar energy, usually workers or engineers need to go to the site to see the process of the solar system. In today's sophisticated era, manpower still needs to be deployed to examine the quantity of electricity generated by the solar system. The process needs to be carried out regularly to ensure that the solar system is always in good condition and able to produce enough energy. The quantity of electrical energy produced from the solar system must be observed regularly. In this study, a solar power system is constructed with IoT to monitor the system remotely and also solar tracking system to obtain optimum solar energy. The solar power system in this study is used to supply power to the gateway station of monitoring platform for gaseous ammonia. The purpose of the monitoring platform is to detect gaseous ammonia and send the data wirelessly to an IoT system that can be observed through a software suitable for the project. This project used a 85 115mm 80 milliampere and 1.5 watt high efficiency solar panel, 12 volt/24 volt rated voltage, 10 ampere rated current, 50 volt maximum PV voltage, 130 watt maximum PV input power solar regulator, and 12 volt rechargeable battery. Then the dual axis solar tracker system is constructed using Arduino Uno, LDR sensor module, servo motor, and 12 volt battery. The monitoring system is constructed using NodeMCU ESP8266, current sensor, voltage sensor, and LDR. For literature review, in bracket 1, design of a solar tracking system using the brightest region in the sky image sensor. The project is using the sky image sensor to sense the brightness of the sky and acts as a trigger for the solar panel to brightest region of the sunlight. In bracket 2, the implementation of solar tracker using Arduino with servo motor. This project used the same method that is using the LDR as the sensor to sense the presence of the sunlight and trigger the servo motor that holds the solar panel and rotates towards the sunlight. In bracket 3, low-cost monitoring system for solar farm using agent technology. The project presents a multi-agent monitoring system for a solar farm that allows the main indicators of solar panels to be controlled with the aim of detecting early faults and taking steps to solve them in various science fields. The use of multi-agent system is widely used because they provide abstraction and intelligence modeling. In bracket 4, solar power remote monitoring and controlling using Arduino, LabVIEW, and web browser. The project proposed an effective and powerful graphical user interface (GUI) for real-time control and monitoring of DC power generated locally and remotely by solar panels and DC power consumed by loads. The server and the client are given two GUIs. For methodology, this is the dual axis solar tracker flowchart. Initially, the servo motor, horizontal and vertical servo are in initial position. Then the Arduino will read the LDR value. Then it will control the servo motor for horizontally and vertically. This is for the horizontal servo motor. If AVT is higher than AVD, it will move the move axis to 175 degree. If AVT is lower than AVD, it will move the x-axis to 5 degree. For the horizontal servo motor, if AVT is lower than AVD, it will move the y-axis to 60 degree, and if AVT is higher than AVD, it will move y-axis to 1 degree. Then it will read the voltage of the solar panel. This is a solar monitoring system flowchart. The NodeMCU will read the sensor value. It will check the sensor values and determine the light intensity, current, and voltage value. And the data will send to the monitoring platform, that is UBDOTS. For results and discussion, this is a performance testing of dual axis solar tracker and monitoring platform. This is the hardware of the dual axis solar tracker, and this is the gauge meter in UBDOTS. The gauge meter shows the current of the solar panel is 8 ampere. The LDR1 is show to the value of 1. Same to the LDR2 and LDR3, and LDR4 shows the value of 0. The performance of a dual axis solar tracker was functioning in grid condition when tested using the lamp rather than sunlight. The LDR can read the light intensity of the lamp better than the sunlight. The monitoring system also functioning well, but not as expected due to the problems that came from the components used. The problems came from the voltage sensor module that broke during the testing session, and the LDR can't read the light intensity of sunlight properly. From the data that has been observed, the LDR is not suitable for the sunlight intensity measurement. Overall, all the systems were working and functioning based on the objective of the projects. In conclusion, the solar power system is very compatible and convergence with the dual axis solar tracker and solar monitoring system. The full performance of the solar power system can be monitored every minute. The dual-axis solar tracker has increased the performance of the solar power system effectively because the LDR can track the position where the direction of the sunlight hits the most. This is the reference used in literature review. I think that's all for my presentation. For the next video, I will show you the performance testing video.